When installing a single receptacle on an individual branch circuit, selecting the correct ampere rating is essential for safe and compliant electrical installations. The ampere rating determines the maximum current a circuit can handle, impacting the types of devices that can be safely connected. Let's explore the common ampere ratings for single receptacle installations, proceeding from the lowest to the highest. Firstly, a 15 amp rated receptacle on a 15 amp individual branch circuit is a common configuration. This setup is typically used for general purpose applications where the connected load is relatively low. Examples include lamps, small appliances, and electronic devices. The branch circuit wiring must be rated for at least 15 amps, which typically involves using 14 American wire gauge copper conductors. The overcurrent protection device, such as a circuit breaker, must also be rated at 15 amps to protect the circuit from overloads. Secondly, consider a 20 amp rated receptacle on a 20 amp individual branch circuit. This configuration provides a higher current carrying capacity, making it suitable for devices that draw more power. Common applications include kitchen appliances, power tools, and other equipment with moderate power requirements. The branch circuit wiring should be rated for at least 20 amps. This typically requires using 12 American wire gauge copper conductors. The overcurrent protection device should be a 20 amp circuit breaker to ensure proper protection. Thirdly, a 30 amp rated receptacle on a 30 amp individual branch circuit is generally used for heavy-duty applications requiring substantial power. Examples include large power tools, industrial equipment, and specific appliances designed for higher current loads. For a 30 amp circuit, the branch circuit wiring must be rated for at least 30 amps, often necessitating the use of 10 American wire gauge copper conductors. The overcurrent protection device should be a 30 amp circuit breaker. Several factors influence the choice of ampere rating for a single receptacle installation. These include the anticipated load, the type of equipment to be connected, and compliance with local electrical codes and regulations. It is crucial to select an ampere rating that adequately meets the load requirements while also ensuring safety and preventing overloads. When assessing the anticipated load, consider the power consumption of the devices that will be connected to the receptacle. This information is typically found on the equipment's nameplate, which specifies the voltage and ampere requirements. Add up the ampere ratings of all devices that may be used simultaneously to determine the total load. The receptacle and branch circuit should be rated to handle this total load without exceeding their capacity. The type of equipment to be connected also influences the choice of ampere rating. Different types of equipment have varying power requirements. Some devices, such as lamps and small electronics, draw relatively little current and can be safely connected to a 15 amp circuit. Other devices, such as power tools and appliances, require more current and may necessitate a 20 amp or 30 amp circuit. It is essential to select an ampere rating that is appropriate for the specific equipment being used. Compliance with local electrical codes and regulations is paramount. Electrical codes, such as the National Electrical Code or NEC, provide detailed requirements for electrical installations, including the selection of ampere ratings for receptacles and branch circuits. These codes are designed to ensure safety and prevent electrical hazards. It is important to consult the relevant electrical codes and regulations to ensure that the installation complies with all applicable requirements. In addition to selecting the correct ampere rating, it is also important to install the receptacle properly. This includes ensuring that the receptacle is securely mounted, properly grounded, and connected to the branch circuit wiring in accordance with the manufacturer's instructions. Improper installation can create electrical hazards and compromise the safety of the installation. Grounding is a critical aspect of electrical safety. A properly grounded receptacle provides a low impedance path for fault current, helping to protect against electric shock. The grounding conductor should be connected to the grounding terminal on the receptacle and to the grounding system of the building. The grounding system should be properly bonded to the earth to ensure effective grounding. Overcurrent protection is another essential safety feature. Circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. When the current in a circuit exceeds the rated capacity of the overcurrent protection device, the device will trip or blow, interrupting the flow of current and preventing damage to the circuit. It is important to select an overcurrent protection device that is properly sized for the branch circuit and the receptacle. Wiring methods also play a significant role in electrical safety. The branch circuit wiring should be installed in accordance with the applicable electrical codes and regulations. This includes using the correct type and size of conductors, properly securing the wiring, and protecting the wiring from physical damage. Common wiring methods include using non-metallic sheath cable or NM cable, metal-clad cable or MC cable, and conduit. Each wiring method has its own advantages and disadvantages, and the choice of wiring method will depend on the specific application and the requirements of the electrical code. Receptacle types vary depending on the intended use and the ampere rating. Standard receptacles are designed for general-purpose applications and are available in 15 amp and 20 amp configurations. Special-purpose receptacles are designed for specific applications, such as ground fault circuits, interrupter or GFCI receptacles, which are used in damp or wet locations to protect against electric shock, and arc fault circuit interrupter or FCI receptacles, which are used to protect against electrical fires caused by arc faults. The selection of receptacle type should be based on the specific requirements of the installation. Inspection and testing are important steps in ensuring the safety and functionality of an electrical installation. After the receptacle has been installed, it should be inspected to ensure that it is properly mounted, grounded, and connected to the branch circuit wiring. The circuit should also be tested to verify that it is functioning correctly and that there are no faults or hazards. Common testing procedures include using a multimeter to measure voltage and current, and using a circuit tester to verify grounding and polarity. Periodic maintenance is essential for maintaining the safety and reliability of electrical installations. Receptacles should be inspected regularly for signs of damage or wear. Loose connections should be tightened, and damaged receptacles should be replaced. The overcurrent protection devices should also be tested periodically to ensure that they are functioning correctly. Proper maintenance can help to prevent electrical hazards and extend the life of the installation. In summary, selecting the correct ampere rating for a single receptacle on an individual branch circuit is crucial for electrical safety and compliance. Consider the anticipated load, the type of equipment to be connected, and the applicable electrical codes and regulations. Install the receptacle properly, ensuring that it is securely mounted, properly grounded, and connected to the branch circuit wiring in accordance with the manufacturer's instructions. Conduct regular inspections and maintenance to maintain the safety and reliability of the installation. By following these guidelines, you can ensure that your electrical installations are safe, efficient, and compliant. Different applications require different ampere ratings. Firstly, for general lighting and small appliances, a 15 amp receptacle on a 15 amp circuit is often sufficient. This is suitable for bedrooms, living rooms, and other areas where the load is typically light. Secondly, for kitchens and workshops, where high power appliances and tools are used, a 20 amp receptacle on a 20 amp circuit is more appropriate. This provides the necessary capacity for devices like blenders, power drills, and small heaters. Thirdly, for heavy-duty equipment and appliances such as welders, large air compressors, or specialized machinery, a 30 amp receptacle on a 30 amp circuit is necessary. This ensures that these high-power devices can operate safely without overloading the circuit. The National Electrical Code or NEC provides specific guidelines for receptacle spacing and placement. In residential dwellings, receptacles must be spaced such that no point along the wall line is more than 6 feet from a receptacle. This ensures that extension cords are not used excessively, which can create safety hazards. The NEC also specifies requirements for receptacle placement in kitchens, bathrooms, and other special areas. Firstly, in kitchens, receptacles must be installed along countertops and islands to provide convenient access to power for appliances. Secondly, in bathrooms, GFCI protected receptacles are required to protect against electric shock hazards. Thirdly, in outdoor locations, weather-resistant receptacles and covers are necessary to protect against moisture and corrosion. Overloading a circuit can create significant hazards. Firstly, it can cause the circuit breaker to trip frequently, which is inconvenient and can disrupt electrical service. Secondly, it can overheat the wiring, which can damage the insulation and create a fire hazard. Thirdly, it can damage the connected devices, which can be costly and potentially dangerous. To prevent overloading a circuit, it is important to know the total load on the circuit and to ensure that it does not exceed the ampere rating of the circuit breaker. Using a clamp meter can help measure the current draw of individual devices and the total current on the circuit. Selecting the appropriate wire gauge is crucial for safe and efficient electrical installations. The wire gauge determines the current carrying capacity of the wire. Using a wire gauge that is too small for the load can cause the wire to overheat, which can damage the insulation and create a fire hazard. The NEC provides tables that specify the minimum wire gauge for different ampere ratings. Firstly, for a 15 amp circuit, 14 American wire gauge copper wire is typically used. Secondly, for a 20 amp circuit, 12 American wire gauge copper wire is required. Thirdly, for a 30 amp circuit, 10 American wire gauge copper wire is necessary. Aluminum wire can also be used, but it requires a larger gauge than copper wire for the same ampere rating. GFCI receptacles provide enhanced protection against electric shock hazards. They are designed to detect ground faults, which occur when current leaks from the circuit to ground. When a ground fault is detected, the GFCI receptacle quickly interrupts the flow of current, preventing electric shock. GFCI receptacles are required in bathrooms, kitchens, outdoor locations, and other areas where there is a risk of exposure to moisture. SI receptacles provide protection against electrical fires caused by arc faults. Arc faults occur when there is an unintentional electrical discharge between two conductors or between a conductor and ground. These arcs can generate high temperatures, which can ignite nearby flammable materials. SI receptacles are designed to detect arc faults and to interrupt the flow of current, preventing electrical fires. They are typically required in bedrooms and other areas where there is a high risk of fire. When installing a receptacle, it is important to follow the manufacturer's instructions carefully. The instructions will provide detailed information on how to properly mount the receptacle, connect the wiring, and test the installation. It is also important to use the correct tools and materials for the job. Using the wrong tools or materials can damage the receptacle or create safety hazards. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the installation. A qualified electrician has the knowledge and experience to safely and properly install receptacles and other electrical equipment. Electrical permits are often required for electrical installations, including receptacle installations. A permit process ensures that the installation complies with the applicable electrical codes and regulations. It also provides an opportunity for an electrical inspector to review the installation and to identify any potential hazards. Contact your local building department to determine whether a permit is required for your installation. Electrical safety is paramount. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment or PPE, such as safety glasses and gloves. Never work on electrical equipment when you are wet or standing in water. If you are not sure how to do something, ask a qualified electrician for help. It is always better to be safe than sorry. Troubleshooting electrical problems can be challenging, but there are some basic steps that you can take to diagnose and resolve common issues. Firstly, check the circuit breaker to see if it has tripped. If it has, reset it and see if the problem goes away. Secondly, check the receptacle to see if it is loose or damaged. If it is, replace it. Thirdly, use a multimeter to check the voltage and continuity of the circuit. If you are not sure how to do this, consult a qualified electrician. When replacing a receptacle, it is important to choose a replacement that is compatible with the existing wiring and the intended application. The replacement receptacle should have the same ampere rating and voltage rating as the original receptacle. It should also be of the same type, such as the standard receptacle, a GFCI receptacle, or an FSI receptacle. The replacement receptacle should be listed by a recognized testing laboratory such as Underwriters Laboratories or UL to ensure that it meets safety standards. In addition to single receptacles, there are also duplex receptacles, which have two receptacles in one housing. Duplex receptacles are commonly used in residential and commercial buildings to provide convenient access to power. They are available in 15 amp and 20 amp configurations and can be used in place of single receptacles in many applications. However, it is important to ensure that the total load on the duplex receptacle does not exceed the ampere rating of the circuit breaker. Surge protection is important for protecting electronic equipment from voltage spikes and surges. Voltage spikes and surges can damage or destroy electronic equipment, such as computers, televisions, and stereos. Surge protectors are designed to absorb these voltage spikes and surges, preventing them from reaching the equipment. Surge protectors are available in various forms, including power strips, wall-mounted surge protectors, and whole-house surge protectors. Whole-house surge protectors provide the most comprehensive protection, as they protect all of the electrical equipment in the building. Smart receptacles are becoming increasingly popular. Smart receptacles can be controlled remotely using a smartphone or tablet. They can also be programmed to turn on and off automatically based on a schedule or based on the presence of a person. Smart receptacles can be used to control lighting, appliances, and other electrical equipment. They can also be used to monitor energy consumption and to reduce energy waste. Wireless receptacles are also available. Wireless receptacles do not require any wiring. They are powered by batteries or by a wireless power transfer system. Wireless receptacles can be used to add receptacles to a room without having to run new wiring. They are also useful for temporary installations, such as for holiday lighting. Arc fault circuit interrupters or size are a critical safety feature in modern electrical systems, designed to prevent electrical fires. Traditional circuit breakers protect against overloads and short circuits, but they do not detect arc faults, which are often the cause of electrical fires. Size work by monitoring the electrical current for unusual patterns that indicate an arc fault. When an arc fault is detected, the ASI quickly interrupts the circuit, preventing the arc from igniting nearby flammable materials. There are two main types of ASIs: branch circuit ASIs and combination ASIs. Branch circuit ASIs protect against parallel arc faults, which occur between two conductors. Combination ASIs protect against both parallel and series arc faults, with series arc faults occurring within a single conductor. The National Electrical Code or NEC requires ASIs in many areas of the home, including bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters or GFCIs are another essential safety feature in electrical systems, designed to protect against electric shock. GFCIs work by monitoring the balance of current between the hot and neutral conductors. If there is a difference in current, it indicates that some of the current is leaking to ground, which could pose a shock hazard. When a ground fault is detected, the GFCI quickly interrupts the circuit, preventing electric shock. GFCIs are required in areas where there is a high risk of exposure to moisture, such as bathrooms, kitchens, and outdoor locations. It's crucial to test GFCI receptacles monthly to ensure they are functioning correctly. The testing process involves pressing the test button on the receptacle, which should cause it to trip. If the receptacle does not trip, it should be replaced immediately. Tamper-resistant receptacles or TRR are designed to prevent children from inserting objects into the receptacle slots. TRR have spring-loaded shutters that block the slots unless both prongs of a plug are inserted simultaneously. TRR are required in dwelling units and childcare facilities. USB receptacles are becoming increasingly popular. USB receptacles have one or more USB ports built in, allowing you to charge your electronic devices without having to use a USB adapter. USB receptacles are available in various configurations, including Type A, Type C, and combination receptacles. They are a convenient way to charge smartphones, tablets, and other USB-powered devices. Smart home integration is transforming the way we interact with our electrical systems. Smart receptacles, smart switches, and smart lighting systems can be controlled remotely using a smartphone or tablet. They can also be integrated with other smart home devices, such as thermostats, security systems, and voice assistants. Smart home integration allows you to automate your home, improve energy efficiency, and enhance safety and security. Wireless power transfer is an emerging technology that allows you to transmit electrical power wirelessly. Wireless power transfer systems use magnetic fields to transfer energy from a transmitter to a receiver. This technology can be used to power a variety of devices, including smartphones, laptops, and electric vehicles. Wireless power transfer is still in its early stages of development, but it has the potential to revolutionize the way we power our devices. Energy-efficient receptacles can help reduce energy waste and lower your electricity bills. Energy-efficient receptacles have features that reduce standby power consumption, such as automatic shut-off and power-saving modes. They can also be integrated with smart home systems to further optimize energy use. By switching to energy-efficient receptacles, you can save energy and money without sacrificing convenience. The electrical codes are constantly evolving to keep pace with new technologies and to improve safety. It is important to stay up to date on the latest electrical codes to ensure that your electrical installations are safe and compliant. The National Electrical Code, or NEC, is updated every 3 years. State and local jurisdictions may also have their own electrical codes. It is essential to consult with a qualified electrician to ensure that your electrical installations comply with all applicable codes. Electrical inspections are an important part of the electrical safety process. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical installations comply with the applicable electrical codes. Electrical inspections can identify potential hazards and ensure that the installation is safe and properly installed. Electrical inspections are typically required for new construction, renovations, and additions. Electrical safety training is essential for anyone who works with electricity. Electrical safety training teaches you how to identify electrical hazards and how to work safely with electricity. Electrical safety training is available from a variety of sources, including trade schools, community colleges, and online training providers. Electricians are licensed professionals who have the knowledge and experience to safely and properly install and repair electrical systems. Hiring a licensed electrician ensures that the work will be done correctly and that it will comply with all applicable codes. Licensed electricians are also insured, which protects you from liability in case of an accident.